In this video, we will discuss two-dimensional arrays. But why stop at 2 dimensions? Maybe we can have 8 dimensions, 9 dimensions, as many dimensions as we want. But first I want to talk about parallel arrays. And this video assumes that you've already reviewed the video on arrays and all the videos that came before that. So let's get started. Here's our view of memory. I've created 2 arrays, names and grades, and I've put them side by side so you could think of them as parallel. They do not have to be stored in memory side by side. They could be, the grades one could be over here and the names array can be down here. In the center I have the index for that first entry in the names table and first entry in the grades table. Let's say my names are full of class members. So I have John, and I have Sue, and I have Frank. So the names array have just names of students. The grades array has the grades of that student whose index is the same. So in grade sub 0, we have a grade. Let's say 85. So in grade sub 0, we have 85, and in name sub 0, we have John. We could think of this as John's grade is 85 because they share the same index. With Sue, let's say her grade is 93, and Frank's grade is 74. So, in grade sub 0, we have John's grade. In grade sub 1, we have Sue's grade because name sub 1 equals Sue and grade sub 1 equals 93. Now we don't have to have just one column of grades. Let's say we have midterms. Well, we could have another column for midterm 1 and midterm 2 and the final. So we could have one dimension which consists of the rows, and we could have n dimensions which consists of columns. So that's what we consider an n-dimensional array. Let's go to some code now. I will go back to our for statement. If you remember our for statement when we looked into it, we were simulating a chess set. Let's run this. Here we've just written to system output. We've written to the screen. That's not too useful, so let's modify this. I've made some modifications to our program and I'd like to discuss them with you. So I've created a constant called board size. Since our board is an 8 by 8 matrix, 0 to 7 rows by 0 to 7 columns, that is our size of the array. You set an n-dimensional array by setting the number of rows by the number of columns. Simple as that. Now this is a double for loop just like we had before, except in this case I'm setting the cell location of the board to true or false. True will signify a board piece is on that cell location. False signifies there is no board piece in that cell location. What am I doing here? Does anybody have any guesses? If you want to think about it a bit, please pause this video. Otherwise, if I equals j, remember I is the row, j is the column. So if I equals j, what I'm really doing here is isolating the diagonal. So if the row 0, column 0 is the cell I'm on, that'll be set to true. If row 1, column 1, set that to true. Row 2, column 2, and so on until we get to row 7, column 7, that'll be true also. So I'm isolating the diagonal and setting each cell location of the diagonal to true. In this loop, all I'm doing is printing out the chessboard. So let's run this. Press F5. I've already run everything. Let's look at it. Here is the chessboard. It is 8 rows by 8 columns, and I'm putting a 1 in all the diagonals. What we can tell from this is 0 means false and 1 means true. So the internal representation of true in C++ is a 1, and the internal representation of false in C++ is a 0. Things to remember in n-dimensional arrays is that you have the number of rows and the number of columns. Just like with arrays, these values should be constants. And you signify a cell of this chessboard as chessboard sub I sub j. This is getting the ith row and the jth column. That's all there is to it with n-dimensional arrays. This concludes the video on n-dimensional arrays.